Hey guys, welcome back. Today we're going to talk about solving systems of inequalities. So the last unit we did, we solved systems of equations. Now we're going to have inequalities. So if you remember, inequalities are less than or greater than or less than or equal to or greater than or equal to. Okay, so they consist of a system of inequalities consists of two or more linear inequalities with the same variables. We're just going to be using two different linear inequalities. The graph of the system of linear inequalities is the graph of all solutions of the system. So we're going to be looking for shading areas, and the area where the shading overlaps the two linear inequality will represent all of the solutions of the system. So the thing we need to remember when we're multiplying or dividing by a negative, we need to remember to flip the inequality symbol. So the steps to graphing a system of linear inequality: we graph each inequality. We use a dashed line for greater than or less than, and we use a solid line for greater than equal to and less than or equal to. The area where the graphs overlap represents the solution of the system. So let's start out with the first example. If you notice, they're both already in slope-intercept form. So when we start out and we graph, we start at our y-intercept of -2. So this will be the first one. We'll do 1 and 2. First one will start at -2, and our slope is going to be a -1. So it's going to be this set up this way. Okay, up 1 over. Okay, now if I notice with the first example, it's actually greater than, so that means I need to have a dashed line. So I'm going to have a dashed line here. Okay, so there's my inequality for the first one, but I need to shade it. So I like to test the point 0, 0. So when I test 0, 0, I plug in the point 0, 0, and I end up with 0 is greater than -2. Well, that is a true statement. So that means that my shaded area will be on the side where 0, 0 is, and it will be shaded like this. Okay. Okay, now the second inequality is y is less than or equal to 3x plus 5. So I start at my y-intercept of 5. My slope is going to be 3, so I'm going to go down 3, 1, 2, 1, 2, 3 into the left one. That gives me that positive slope. Okay, so down 3. All right, and that one is less than or equal to, so that's going to be a solid line. So it's going to look like that. Okay, so now when I test the point 0, 0 for number 2, I end up with 0 is less than 3 times 0 is 0, 0 is less than or equal to 5. So that would be true. So on this side, we would have this 0, 0 sided shaded. So the area that we're interested in is actually this double shaded area. This is where all the solutions would be. So the solutions would be right in this region right here. Okay. Notice all of the ordered pairs in that region would be a solution. Now, any point on this line, the dashed line, would not be included because it's a dashed line. So say, for instance, I asked for the point 0, -2. It's on the dashed line. That would not be included. However, the point 0, 5, because it's on the solid line, would be included as part of the solution. Okay, so if you guys want to pause and try number 2, they're both already in slope-intercept form. You can pause it, but I'm going to continue on. We start out with number 1 and number 2. So y is less than x minus 4. My y-intercept is -4. And then my slope is going to be a +1. So it's going to look like this, and it's going to be a dashed line. Okay, when I check the point 0, 0, I end up with 0 is less than -4, and that's a false statement. So that means that point 0, 0 is not going to be in the shaded area. The other side's going to be shaded. So it's going to look like that right there. Okay, now the second line, when I do it, I've got a +3 as my y-intercept, and my slope is -1. So it's going to look like this. Okay, but in this case, it's greater than or equal to, so I'm going to make a solid line. Okay, and then when I check the point 0, 0, I end up with 0 is greater than or equal to 3. That would be a false statement. So that means I don't want to shade the solid side. I mean the 0, 0 side. I want to shade the other side here. So this is going to be this area here. Let me get it. We'll do this one in green. All right. Let's get this green. So the only double area is going to be right in here. It's hard to see with the colors, but right here would be the solution. Okay, so we're looking for the overlapping area. Okay, So our inequalities are not always going to be in slope-intercept form, so that's going to be your first step. So we're going to take the first, I'll do the first and the second. We'll get y is going to be less than negative 2x minus 3. Okay, that's our first one. And then when we graph that, we've got a negative 3, slope is negative 2. So it's going to go up 2 over 1, okay, and it is less than, so it's a dashed line. Okay, and then when I test the point 0, 0, I end up with 0 is less than negative 3. That's false. So that means when I shade it, I don't shade the 0, 0 side, I shade the other side. So there's my shading on the first. Okay, the second one. All right, I'm going to put it in slope-intercept form. So negative y is going to be less than or equal to negative 2x minus 1. But when I multiply or divide both sides by negative 1, I've got to remember to flip the inequality. So y is greater than or equal to 2x plus 1. Okay, all right, so there's my y-intercept is at 1. My slope here is going to be 2. Okay, so it's going to look like this, and it's going to be a solid line. Okay, when I test the solution 0, 0 right here, it's pretty close, but 0 is greater than or equal to 1. That's actually false, so that means I'm going to shade the other side. I'll do that in like a pink. Okay, so I'm going to shade this side here. So immediately here you can see this is the double shaded area. You don't even need to shade up here. Okay, but right here, this would be the solution area. Okay, so you can go ahead and try number 4. And again, you've got to just remember to put it in slope-intercept form. So 4, 5, and 6, I'm going to have you try them and then compare them with the answer key instead of walking through it. Okay, it takes a little bit of time. Okay, so I'm going to jump ahead to number 7 for purposes of the notes in the instructional video. When we get to number 7, we're going backwards. Okay, now we're going to write the system of linear inequalities represented by the graph. Okay, so this is a little trickier. You got to keep yourself organized. I'm going to identify my first graph and then my second graph right here, my line, 2 linear inequalities. Okay, so for number 7, the first thing I want to do is identify the slope and the y-intercept. So the slope here, the y-intercept for number 1 is going to be positive 2, and my slope is going to be negative 1/2. Okay, so when I put it in slope-intercept form, I've got my y, negative 1/2 x plus 2. Okay, so now I know it's a dashed line, so it's less than or greater than, but I've got to figure out if it's in the shaded region or the not. Okay, so the 0, 0 point for line number 1, it looks like it is in the shaded region because the whole thing here would be shaded down. Okay, so that means this statement, if I put in 0, 0, 0, and 2, this needs to be true. Well, 0 is going to be less than, okay, less than 2. So that would make it a true statement. That's what we're looking for. So the first one would be y is less than negative 1/2 x plus 2. Now the second equation, okay, if I look at that, my y-intercept is going to be at negative 1, and my slope, okay, my slope is going to be at, we're looking at number 7. So that one's a little bit off. Hold on. Okay, my second one, my y-intercept is at negative 3. Okay, so 2, my y-intercept is negative 3, and my slope is also at negative 3. Okay, so when I look at that, it is also dashed, so I know it's going to be greater than or less than, but I'm going to put in negative 3x minus 3. Okay, and if I look at that, in this case, 0, 0 again is going to be in the true area, so that's got to be true. So when I put in a 0 and a negative 3, I need a true statement. So actually 0 is going to be greater than negative 3. Okay, so the 2 inequalities represent the system of linear inequalities. They would be together. Okay, so you guys can try number 8. Actually, I'm going to give you number 8. It's a little bit off. It's hard to see through the shading. So for the very first one, we'll look at this. Our y-intercept is going to be at let me see, our slope is actually going to be 5/3. So look at this, 1, 2, 3. So our y-intercept is going to be at 3. And our slope is going to be at 5/3. Okay, and that's going to be for this line right here. We'll use that as number 1. Number 2 line, we're going to use, we've got a negative 3 as our y-intercept, and our slope is going to be negative 1/3. Okay, so In the case of number 1, it would be a true statement because 0, 0 is in the true region, and actually for number 2, if we're shading upward, it's also going to be true. So we need to make them both true if we put in 0, 0. So for number 1, we've got y, and we've got, let's see, 5/3 x plus 3. We want 0, 0 to be true, so 0 and 3 to be true would make 0 is going to be less than, and it's a solid line, so it's less than or equal to. So there's the first one. And then the second one, we've got y, and then we've got 1/3 x minus 3. So when I look at that, okay, 0, 0 is also going to be true, so 0 and negative 3, when I plug in 0, 0, that needs to be a true statement, and 0 is going to be greater than, okay, so that's going to be greater than. So these two would represent the system of inequalities, okay. So again, going ahead and doing 9 and 10 on your own and then comparing it to the answer key, this would be a good point to break it, okay. And we'll look at 9 and 10 now for 11 and 12. All right, number 11 and 12, you're given the solution and you have to identify the two inequalities. So this one's a little easier. You've got your dashed line. It's a horizontal line, so you know it's y, and it's going to be, if you notice, it's dashed, so it can't be these two options, okay? Is it greater than negative 1/3 or less than 1/3? Well, it's shaded below the line here, so it's actually going to be less than, not 1/3, but 3, negative 3. Okay, so we'll have y is less than negative 3. And then when we look at the other line, okay, if you notice the shaded area needs to go to this way, right? In order to get that double shaded area, that means that 0, 0 is false, okay? So we know it is a solid line, so it can't be these two because one is less than, one is greater than, okay? But if we put in 0, 0, we would get 0 is less than or equal to 1. That would actually be a, let's see, it's going to have to be in the false statement. So see how it's to the left? So this 0, 0 needs to be false, and that one's true. And in this case, we put in 0 is greater than 0 plus 1, okay, which is false. So we're looking for the false statement, so that would be the answer, okay? All right, so you can go ahead and try 12. And 13, it's very similar. We're just looking for the shaded region. You can actually just put this one into Desmos if you want, or you can shade them both. And you can see that your answer should be in region 4. But if you put it in slope-intercept form, y is less than negative 2x minus 2. And then you'll also have y is greater than or equal to 2/3 x plus 2. So when you shade both of those, you're going to find that region 4 is the one that is double shaded. Okay. Now, for number 14, for the following system of inequalities, determine which ordered pair satisfies the equation. All you're going to do is plug in your x and your y for A, B, C, and D. Okay, and if you did that, you would have, and it's got to be true for both, so for it to be a solution, so it's got to be true for both. Okay, in this first case, I'd get negative 3 is greater than negative 1 1/2 plus 1. So that's going to be a negative 3 is greater than 1/2 when we add them, and that's a false statement. So as soon as we hit that false statement, we can move on. All right, now for number 2, whoops, let's get that back. Number 2, if we plug in our y is 2, is greater than 1/2 times 1 is 1/2 plus 1. 2 is greater than 1/2, so that one's true. Now we try the second one, and we get 2 plus 3 times 1 is 3 is less than or equal to 6. That one's true. So far it looks like it's B. We'll check the other two. As soon as I plug into 0, I end up with 0 is greater than 1 plus 1, which is 0 is greater than 2. That's a false statement, so I can move on. And then for D, when I plug in, I've got 6 is greater than 4 times 1/2 is 2. 2 plus 1 is 3. So 6 is greater than 3. That one's true. But then when I plug in 6 plus 3 times my x, which would be 3 times 4 is 12, and that's going to be less than or equal to 6. That's going to be a false statement. So for number 14, it would be true for both. The other thing you can do here is put both of these into Desmos and look at these ordered pairs. You should see that the ordered pair 1, 2 is actually in that double shaded region. Okay, so that's an easy way to check it. All right, and then going to number 15, I'll have you try that on your own, and then you can compare it to what is on the answer key. Okay, so that's all for day 52. Thanks.